All right. Thank you, everyone, for coming to tonight's archaeology presentation. And the title of this presentation is Westwood, an Ancient Native American Site. And Dr. Jim Gibb will be our guest speaker for tonight. So, in just a moment here, he's going to share his screen and talk a little bit about tonight's topic. So, with that, take it away, Dr. Gibb.
Thank you, Allison. Okay, anyway, yeah. So I'm going to talk tonight about a site that my crew and I excavated this year, actually this summer. It's a project we'd actually started back, I think, in 2015 when we initially found the site and did some initial testing. But it's this year that we finally got to take that site apart and try to learn something from it. So that's where we're going. So the site is in the north central Charles County, right up along the Mattawoman Creek, as you can see on this map. And on this old, I think it's 1944, 1944 U.S. Geological Survey map, again, you can see the location of the site. Notice that it's on the south bank of the Mattawoman Creek, which is the boundary line at this point between Prince George's and Charles counties. So we've got some relatively level land on either side of this fairly substantial creek with lots of tributaries. The area is just loaded with Aboriginal sites, although many have been destroyed through mostly residential subdivision construction in recent years. Well, we went out to the site in 2015. It was a fallow farm field, fairly small, I think 6 or 8 acres, beginning to get overgrown. It was a tobacco barn, this tobacco barn in the middle of it. And the site that we found is just to the left of the image you see here. Don't worry about the details of this map. But the site you can see is generally towards the center of this parcel of land. But what I want to draw your attention to is that when we did a shovel test pit survey, looking for archaeological sites on this parcel, we found a second site just to the southwest on this higher ground here. And that site dates to probably the early 19th century. And there were Aboriginal artifacts there as well from what we call from the early Archaic, late Archaic, and transitional periods. So there's a strong Native American appearance that existed there. However, we couldn't do much with that site. It was clearly that most of it had eroded away. There was very little soil left up there. And that soil, of course, migrated to the northeast. It moved downhill. And that's an important element of this evening's story. So focusing in on where that barn is located, in the left-hand side, you can see all those little circles. Those are our shovel test pits. They were excavated roughly 25-foot intervals across the site. This is after we initially found the site. So we did this close interval shovel testing to see if we can narrow down its location. And you can see from the image on the right-hand side where these contours lines are. This is where the site is concentrated, just to the southeast of the barn. Those 3 black squares are test excavation units that we dug after identifying where the material is concentrated. Now, some of these lines head off to the north. That's just an artifact of the simulation program that I used. They don't really mean very much. You can really see where the concentration of material is located. So we dug 3 of these excavation units in the middle of that concentration. And you can see the upper portion here, this light brown material. This is all plowed soil. And the image doesn't do it justice. It was very, very gravelly. And it clearly had been redeposited. This soil could not have been in that location for terribly long. It looks like it's material from the southwest that through plowing had eroded down the slope and covered the site. But in that material, we found, early 19th century material. We found Native American artifacts of different periods. The important part, however, is at the bottom of it, you can see this dark layer of soil. Initially, I thought that was also a plowed soil, but a very old one. And it turns out from our work this year that that's not the case. Part of it probably has been lost to plowing, but that soil is an original topsoil that has been buried by all that eroded material. Think of Pompeii being covered by volcanic ash. Well, this is a site, much smaller scale, of course, that's been buried by eroded soils. Underneath that dark brown, what the trowel is sitting on is a yellowish brown soil, a little finer grained. That both the dark material and the yellowish brown material both yielded a large number of Native American artifacts. So these profile drawings of the three units give you some sense. This is after we excavate the units, we scrape down the walls, we measure and we draw, and you can see each of these has a plowed soil that has not been weathered. That is, it hasn't been affected by chemical and physical weathering that would give it a more consistent texture, more organics. It's relatively recent. How recent, we can't really tell. It's got 20th century material in it. Underneath, on this old drawing, we have the buried, what I call that a buried plow zone, is actually a buried topsoil, which would be a BA horizon rather than a BAP horizon. Underneath that, following the reclassification of these soils, we're calling that now a BE horizon. Don't worry about what those terms mean. Suffice it to say that the two lower ones are intact soil horizons that contain Native American artifacts. When we went out there this year, we found the points that we used to map the site back in 2015. So in surveyor's language, we reoccupied those points. We set up our total station on one of them, which you could see here, and we backside on the other one, which is at the edge of the woods here. You could see some clumps of branches and everything. This was covered with dense underbrush. Before we got out there, the property owner had hired a group of folks to come out and bush hog that to clear it so we could actually work it. It would have been impossible otherwise. So here we are in 2015 in the summer, and what we did was we dug these 10 excavation units that you see on the left-hand side. You could perhaps see the smaller original units 1 through 3 to 3 foot by 3 foot ones from 2015. We excavated each of those stratigraphically, and on the right-hand side, you could see an image of what a typical unit would look like, both in profile, which you see west wall and north wall here, where you could see not only that redeposited soil that's been plowed, but there's even an earlier plow zone, an earlier redeposit of plowed materials. And it had gotten so deep at this point that as the farmers continued to plow, they could no longer plow to the depth of the material that had been redeposited. That's how quickly it came down. My guess is this stuff formed in the mostly in the 20th century. And below that darker material, that's our buried topsoil and a subsoil beneath that. Again, the lower two both having lots of artifacts. In plan view, you can see this square in the upper left labeled BA. You can see there are two plow scars that run across it. That tells us that the soil above was plowed and the plow had dug into this buried A horizon. My guess is it dug in quite a bit over the years and we've lost a lot of it. Underneath that, the so-called BE horizon, no plow scars. Since there are no plow scars, that means that buried topsoil had not been plowed. It had been truncated by plowing, but had not itself been plowed. So whatever is in that BE horizon has not moved in the centuries since that material was originally deposited. So here's a view of working view of one of our excavation units. In the center, you can see one of our old shovel test pits, and you can see these linear bits of soil, lighter colored soil. Those are the plow scars. And if I were a decent photographer and did a close-up view of the darker material, you would see little swirls of the yellowish brown soil in that as well. And what that tells me is that buried A horizon, that buried topsoil, had been subjected to flooding or storm water movement. It's been churned up, not recently. And one of our units, after we were through digging our excavation units, we had a backhoe on site, so we extended one of those units, Unit 9. And here you could see we've got the recent growth since the field went out of cultivation. It's the upper part of the plowed soil, again, very gravelly material. Underneath that buried what we call an A horizon or topsoil, a BE horizon below that, and below that a BT. The cultural material is largely from this dashed white line up. Below we have something called a BCG horizon, which is just a way of saying lots and lots of gravel, no artifacts in there, and actually the water table rising up through it. We took soil samples from each of these horizons. And what we did was we brought them into the lab, and we put these samples in these little metal cups, and we weighed them, keeping track of each sample. And then we put them in these, what looks like a large pizza oven over here in the lower left-hand corner, overnight at about 200 degrees Fahrenheit to dry out the soil. Then we weighed the soil again. The difference in weight is the loss of moisture. We then took each soil sample in turn and put it in this rotating drum that you see in the upper left-hand corner, piped in water, and just let it roll for a while and let the water gently flow out with all the lighter sediments. Once we did that, we empty it out, dry out that soil sample in the oven again, and reweigh it. The difference in weight after washing that soil from before washing it, that is the loss of silt. And I'll get back to that in a moment. After we dried out each sample, we put it into the shaker screens over here. These are graduated screens from largest around half an inch to very fine, super fine. And in the middle, pay attention to this one here, the number 60 screen, that's around 250 microns. I'll get back to that in a moment. But with the machine, we just shake this stuff. And so the soils would flow down naturally and get caught up in the various sieves underneath. We would then empty each sieve into a little Ziploc bag. Well, we'd weigh it first, and then we put in a Ziploc bag. So we've archived these materials. And then looked at the distribution of the weights. So I think perhaps the thing to focus in on is the right-hand side of the graph here. It's called a cumulative frequency curve. Don't worry about that too much. But the red represents the stuff from the upper plow zone, the green from that little bit of lower plow zone, the purple, I guess you would call it, for the buried topsoil, the light blue from the BE horizon. What this graph is telling us is that the upper two plowed soils have a lot more coarse grain material, and the lower two have fine grain materials. So the soils from these four different strata, they all have the same source, but the upper ones are far more coarser grain, more gravel, more coarse sand. And if we look at just what we've lost in washing those soils and reweighing them, about 22% of that upper plow zone was lost. So that's basically silt, very fine silt. 24% for the lower plow zone, for the buried topsoil, 35%, and for the BE horizon, 45%. That's how much of the weight was lost when we removed the very fine sediments. So that tells you the very clear physical differences between these soils. Now, the upper stuff, there are areas of the site that have not been plowed or forested now, but the woodchucks have been getting into. And you can see what we're looking at in terms of gravel. And this is the kind of material that was being exposed and washed down the hill. And we also found fairly large cobbles. The scale on this is 5 centimeters, that's 2 inches. So these are pretty big rocks. And these are the kinds of rocks we see lying around on the surface. And they're broken. They've got these large flakes. These are quartzites, large flakes taken out of them that were used for tools. So there's a wide range of stone sizes that appear on the site. That's 60, number 60 sieve, 250 microns. I took a photograph of the contents of each at the same scale, and you can see that from each of these deposits, it's the same material. It's a coarse, subangular, medium coarse sand. They really look alike, except for the lower two, or have more mineral staining, which suggests they've been in place a little bit longer than the other material. So manganese perhaps is formed around individual sand grains. While we're out there and had a backhoe, we also dug a trench. This is only half of it dug at this point. That's George Reisling taking a look at things. In our initial work back in 2015, we think we found a relic stream bed. This is a stream bed that hasn't functioned in we don't know how long. Large part of it has been destroyed by development, as you can see in the background. But we did another project a few years earlier, a little further east, a turf farm. And when you go out to the back of that turf farm, you can see this old valley, this old stream valley that doesn't have water in it anymore. That stream valley has been vacated. The stream no longer flows through there. Whether that was originally whether that was the original Mattawoman Creek or a tributary to it, I don't know. But it used to flow through this part of the property as well, and that probably accounts for why the Native American site is there. When we were trenching, we had hoped to climb in there and scrape down the walls and draw nice profiles and everything, but since it's all sand and gravel, all of it just kept collapsing. We couldn't get within 2 feet of the edge, as you can see in the middle ground on the left-hand photograph. But look at all that water that's accumulated in the east half of the trench. That's the stream, the old stream channel. In the upper right, as you get further and further to the left, to get away from that stream channel, we get less and less gravel in the soil. And the lower right-hand side, perhaps you can see there's a relatively recent old stream channel that is filled in with silt on top of gravel. So it shows up here as a sort of light yellowish brown fine sediment. And that's what came out of the trench. And that characterizes a lot of that site. Once you go through the first couple of feet of sandy sediments, you hit it's just an incredible amount of gravel. And that gravel, again, uphill was probably exposed to erosion and started migrating down the hill, which would account for the gravelly nature of the soil up here. Again, the photographs don't do justice. We did too good a job of scraping it down with our trowels. These are incredibly gravelly soils. When we looked at the artifacts from the buried topsoil and the subsoil, just from all the units together, you could look at the distributions here along the bottom of the various tool types. You don't need to worry too much about what they are, although some of them is pretty obvious. A hammerstone, bifaces, essentially a knife, end scrapers, projectile point, the far right-hand side. But in the aggregate, for those 10 excavation units, the distributions are very similar. incredibly similar, which suggests that they're really all the same deposit. And the difference between the buried topsoil and the buried subsoil, it has to do with weathering and the development of soils out of that BE horizon. And what I'm suggesting here is that analytically they could be lumped together. And this is the same sort of graph, except we're looking at for the 10 excavation units. And for the buried A horizon to the left and that BE horizon on the right. And you can see again, the distributions are very similar. Now, what this is suggesting is a degree of homogenization of the artifacts across the site, which is not really good news for us scientifically, because it suggests that we don't have areas clearly defined, what we call activity areas, an area in which somebody was just cooking, hence the fire-cracked rock that's produced as pebbles or fractured by being heated up and then immersed in a cool liquid to cook that liquid. It suggests all this deposit of artifacts not only does it not differ between those two principal strata, but also has been kind of smeared across the site. We don't have clearly defined activity areas. When we looked at the stone tools, and this is a site that probably goes back somewhere between 4,000 and 5,000 years. The only thing that really survives is stone. These people did not have pottery, which would have preserved. Most of their material culture consisted of fiber, clothing perhaps, and all sorts of bags and cordage and everything made of local plant material, perhaps a lot of leather from hides from hunted game. All that really survives is rock. That's what we have to work with. For the site in the aggregate, about nearly 2/3 of the stone consisted of quartz. This is flake stone, stone resulting from the manufacture of stone tools. Quartzite, about 1/3, and very little of anything else. We did have 42 bits of rhyolite. Meta-rhyolite is a stone that comes, the closest area would be the Frederick area, and that suggests some sort of connection between northern Charles County and Frederick. Were these people moving physically? Were they acquiring this stone through trade? I don't dare say. I don't really have an opinion on it at this point. But it's pretty clear these folks are using predominantly quartz and quartzite, which are stones that appear in those gravels I showed you a few moments ago. If we look at, again, we're really focused on quartz and quartzite. If we look at what that material represents, an end scraper is a stone tool. It's a finished tool. We have one. Projectile points or arrowheads, we've got 15, 29 projectile points, which is a fair number for 10 excavation units. Most of the material we've got is from the manufacture of stone tools. Actually, I forgot up here, bifaces, these knives, if you will, that could be turned into projectile points. We have a total of 27. But most of the material, the decortication flakes, primary, secondary, tertiary flakes, shatter, this is the waste material generated by making stone tools. And decortication is that first step in taking a cobble and kind of knocking off the rind to expose the inner stone from which you can actually make tools. So if you've got people removing the cortical material off a cobble, that means that's the beginning of stone tool making. A primary flake is a large flake that they try to break off using another rock, and it's out of that primary flake that they hope to make a stone tool. Now, it might just be used as is, just a sharp flake that could be used to skin an animal, for instance, and when it gets dull, you just throw it away and make another one. Or you can actually continue shaping it into a tool like an end scraper or a projectile point or a general biface. Secondary, tertiary flakes, that's all part of continually whittling down these stones into a useful tool. So what this tells us is that from both of these principal materials, these folks are making stone tools right there, starting from pebbles about the size, maybe depending on how big your hand is, 2-3 times the size of your fist. Oops. There we go. And you can see here the tools, the flake types from decortication to shatter. Shatter is just flakes that basically we don't know what they are. They're just so broken up pieces of rock, but they're clearly from the production stone tools. But with quartz, you see a large percentage is shatter. With quartzite, the distributions are similar, except they differ. There's a lot less shatter in amongst the quartzite. And that's simply because quartzite is a finer grained material that's easier to work, perhaps it's a little softer. You get really nice flakes, flakes that conform to what you want, what you're trying to do when you break a stone. Quartz, crystalline quartz is just, it's very hard to control the fractures of it. So you get a lot more waste, a lot more shatter. And so that's all that distribution tells us. It tells us that quartzite's better. Now, these are our excavation units and their actual locations. These are all mapped in with our total station. On the left, you see all these green spots. What we did was we mapped in every flake and every piece of fire-cracked rock that we found while excavating. And so when you look at these things, if they look like they're a bit of a blur, that's because we got so much material from each of these units, from each horizon, that there's really no pattern. Now, I will tell you that Unit 5 up top center is not a unit that worked out very well because when we dug it, the soil was very dry, and that to a certain extent true of Unit 7, so it was very difficult to piece plot. In fact, we stopped digging at that point, waited till we started getting some rain. This was in a drought. And Unit 10, we dug less than a half of that. That's in the lower left-hand corner. And that's because when we removed the redeposited plowed soil, we came down on that dark, buried topsoil horizon. And it's kind of funny because it had a hollow sound to it. And that's because woodchucks had mined out the BE horizon underneath. So the soil was just sort of hanging there in place, and we really couldn't excavate it. But at any rate, the map on the left shows the distribution of fire-cracked rocks, which again, they're the unintentional byproduct of heating up pebbles, putting them into watertight containers that couldn't otherwise be put on the fire. And by heating the rocks and putting them into the liquid in these vessels, the liquid would boil and the food would cook. And as the stone cooled down, it would be removed and reheated. That constant heating, cooling, reheating eventually causes stress fractures in the pebble, and eventually it explodes. And we find characteristic remains of those exploded pebbles. We refer to them as fire-cracked rock. On the right-hand side, all the blue, that's the flakes. That's largely the remains of stone tool making. Again, the material is just so dense, we really can't see an area where somebody was cooking versus making stone tools. This is that unit that I mentioned where you could see where Steve Lohr is excavating. You can even see some of the rodent burrow appearing here. But this is the buried topsoil here. You can see part of it is collapsed in. That's because it's a rodent burrow, a huge one that undermines this. Just finding that, however, explains perhaps why the distribution of artifacts is such a muddle. We don't know how long woodchuck's been burrowing around on this site. Their presence, their concentration in this area may have to do with the field having been plowed for a number of years and then left fallow for a number of years. plus the tobacco barn being right there. This is a nice area for woodchucks to congregate. So woodchucks have clearly disturbed the deposits a lot. That disturbance may be relatively recent, like in last several decades. But recent or not, they've certainly caused a great deal of damage. This is just a brief description of the soils. Again, that top plow zone, the sort of buried plow zone, the buried topsoil, and the subsoil beneath. The sorting has to do with the gravel in it. You have a lot of different sizes of gravel, which would be poorly sorted. Well sorted would be, you find gravel, but it's all roughly of the same size. And it has to do with deposition in the water. We found a number of artifacts throughout. In the buried topsoil, we found a little bit of wine bottle glass. Seems to me we found an early 19th century ceramic as well, but that material only appeared to be at the very top and possibly out of those plow scars. Everything else is Native American, and the vast majority of the material of the artifacts that we can actually date were these Brewerton projectile points. I'll get back to those again in a second. This is the same map, but here I'm just showing where we've mapped in the locations of projectile points, which are in red, bifaces, which are knives or projectile points in the making, in magenta, and then hammerstones in black. But here you can see, well, maybe there is some bit of clustering. It's over in the eastern core of the site that these things seem to be most plentiful. And that suggests, maybe there was some clustering of material, some evidence of an area where people were making stone tools, and it's just no longer really clear to us archaeologically. To show you a bit of clustering we did have, in the lower right-hand corner, we have a cluster of firecrack rock, but that's from this unit here. And in fact, there's firecrack rock, which shows up in green all across the unit. It just seemed to be a little more clustered in one corner. And even then, it was just one course, one layer. Once we removed this seemingly cluster of rocks, it was just a fairly uniform distribution throughout. Again, it suggests that there was some clustering there. There was some way of figuring out where different activities occurred, but it just does not survive. Several of the units in that buried A horizon, that BE horizon, we found ash, kind of generally distributed throughout. Little bits of charcoal, not big enough really to recover as is, because that would be great for radiocarbon dating. But in this one unit, Unit 11, we found this feature, which I have in the left-hand image, scratched out with a trowel. That's not a shovel test pit. We know it's not a shovel test pit because we mapped all of our shovel test pits with a total station, and none of them belongs in this particular unit. And in fact, when we excavated, it's kind of a truncated cone. It didn't have any modern material in it. It just had material that was a mixture of that buried A and the surrounding BE horizon. And there was firecrack rock and flakes in it, nothing special. It looks like a pit that had been dug, more recently, not anciently, but not in the 19th or 20th centuries. What was interesting about it is we were able to take out all the soil from that pit and bring it back to the lab, where we water screened it through window mesh, nylon window mesh, using deionized water. So we washed all the soil out and collected the residual charcoal. We sent that charcoal to a lab down in Florida, Beta Analytic, and they ran a radiocarbon assay on it, and the details of which are in the lower left hand of your screen. If you're a professional archaeologist, it might interest you, but it's pretty arcane to most folks. The upshot of it is that charcoal appears to have dated to around the 1400 of this era. So I have 1400 CE, that's Common Era, that's same thing as AD 1400, as opposed to BCE, which is before the Common Era, which is more or less, which is equal to before Christ. What that tells me is that those soil deposits were disturbed in around about 600 years ago. Later deposits, Native American perhaps, maybe just forest fire, but that ash was mixed in with that soil. And so if we're dealing with a site that's 4,000 to 5,000 years old, but we have disturbances just 600 years ago, again, that explains why we're not finding that clustering of artifacts that suggest activity areas. This is just more evidence that these soils have been disturbed. We got a lot of projectile points out of this site. Now, some of these, far left-hand center one, for instance, came from an earlier phase of the site. So we've got a stem point here, perhaps what we call Bear Island from around 3,000 years ago. We've got a Kirk corner notched point that's serrated at what we call early archaic and dates back, I don't know, 5, 6, 7,000 years ago. But most of these projectile points are of the same type. They're the side notched triangular blade points from mostly quartz and quartzite, one rhyolite. So you look at these things, you go, well, I see some of them look kind of like one another, but not all of them. And it looks like there are a lot of different shapes. And the reason being, all of these points appear to have been broken and or resharpened until they really were becoming quite small. So number one over here, for instance, the blade of this projectile point used to be a lot larger, probably something more like number 10. But as it dulled or broke, the person using it would take a stone or maybe an antler or something, apply some pressure and just kind of chip it away until basically reshaping it, sharpening it, to the point where these points probably were no longer functional. They had been worn down so much. Now, when you're doing typologies of artifacts, it's hard to take that into consideration. Is a point a Brewerton point because it looks like, say, number 13, but is number 5 also a Brewerton point that's just been heavily reworked, resharpened? So what we need to do is somehow quantify a point to be able to say that, yeah, it looks like it's of that particular type, and the reason it doesn't look like an ideal Brewerton point is because it's been heavily resharpened. So the solution to this, well, I should say, first of all, I've got these dates in here. You pay attention to the lower ones here. People disagree with what these projectile points date to. And don't worry about, well, the symbols up here. Basically, BP is before present. Plus or minus is give or take, in this case, 115 years. And then because radiocarbon dating is a statistical procedure, it tells you that you could be 2/3 confident that the real date appears within 115 years of this base date here. So 5,630 years ago, give or take 115 years, gives you somewhere between 5745 and 5515 years ago, which equates to basically 3795 BC to 3565 BC. And these are dates from several sites in New York, Pennsylvania, West Virginia. And the people who've worked with this stuff, Jay Custer for one, says, okay, these Brewerton points with these radiocarbon dates roughly between 4,300 and 1,600, or I should say from 1,600 to 4,300 before the Common Era. Justice says 2,000 to 3,700. Bob Funk said 3,100 to basically 4,000. So we're not really confident about the actual date. But I think if you say around uh, 4,000 4,000 years ago, that's a pretty good date for these projectile points. So getting back to the amount of wear on these points, what we did was we used a scanner, a 3D scanner at the lab, and scanned each of these points. Left, this is a 3D scan. It's actually, you could actually rotate this in virtual three-dimensional space. But what I opted for was a sort of face-on view, a side view, and a section view. And it's that section view we're going to draw your attention to. So this is actually a different point here, but I took that sectional view, that scan, and I put it into a drafting program called AutoCAD. And what I did was I basically drew a best fit outline, drew a bunch of lines around the perimeter of this section. And then I drew a line straight across and one perpendicular. So dividing that section up into northwest, southwest, northeast, and southeast quadrants. These have nothing to do with cardinal points. They just, I think, in terms of cardinal points. So we could have called them quadrants 1, 2, 3, and 4. I just find this easier for my brain to work with. But then what I did, we have a dimensioning tool in the software that allows us to calculate the angle from that line I've drawn to basically the cross section. So we've got 40 degrees for the top, 42 degrees for southeast, 26 and 20. And I was able to collect those data, put them into a spreadsheet, and also add those data. So we can look at, let's just see what that looks like. So here are the data. Sorry, all these tools get in my way. So these are each of the points numbered 1 through whatever, 1 through 23. And these are the angles for northwest, southwest, northeast, southeast, and then adding them. So for instance, for the left-hand side, for point number 1, the total degree measurement is 30. I'm sorry, it's 65, 30 is for southeast. And for the right-hand side, it's 66 degrees. So we've got those data. So this again is what we're measuring, what we end up measuring. We've got that total angle here, as well as the constituent parts for both sides. And then we can put that, export that into a smaller table. And we get minimum, maximum, but here's the mean. The mean angle is 34, 31 degrees for southwest, 34, etc. And these, the mean angle for the left-hand side and the right side, 65 to 67. So all I've done here is measure these edge angles. Now, you know what that means? You know what its value is? It has no value. By itself, it has no value. What we need to do is the same exercise on other assemblages of Brewerton points, and we could do this for any projectile point type. And then we'll be able to see the differences in the wearing down of these points and their resharpening. If there's a value to us here, it's that we've quantified how these points have been reworked to the point where many of them were no longer usable. And you might find that a little hard to understand, but let me scoot back for a moment here. These points here, when you think about it, even the larger ones, most of that projectile point is embedded in a wooden shaft or a bone or wooden foreshaft that's connected to the shaft for, let's say, a spear. Very little of that stone is actually exposed. And so it gets, if you continually resharpen these points, they end up getting so small that they're really not going to stick out. they will not be an effective perforation tool that will, perforate the hide, for instance, of a deer. And what this is telling me at this site is that these points had, many of them had reached their end of their shelf life, if you will. And what I think is going on at the Westwood site is that a bunch of folks are getting together 4,000 or 5,000 years ago on the banks of what used to be a creek. And they're a larger group there, and they're doing certain things. And at later times of the year, they're going to break up into smaller groups. And this is what's called a fission-fusion model. And it's based on the idea that these hunter-gatherers, at certain times of the year when there's a lot of resources available in certain areas, they get together, they hold rituals together, they marry off their kids, they make use of some readily available, momentarily rich resource like herring runs. You've got these anadromous fishes swimming up in these creeks to lay their eggs. Well, when they come rolling through in April and May, there's a lot of food to be had. And there may be other resources at different times of the year. When that resource surplus abates, then these folks break up into small groups and move across the countryside, taking advantage of less dense resources. So these are my observations from this particular site. And remember, what we have is just one archaeological site. By itself, it's not very enlightening. It's when we start putting it in the context of other sites throughout the region that it will start making sense for a particular point in the past. So the observations here, first of all, that this is a single component Brewerton Complex site. What does that mean? It means there are a lot of other projectile points from different periods, and collectors have known about this site for many years. And they've been picking out all kinds of artifacts. But it looks like most of those artifacts they were picking up came from redeposited soils. And that underneath those redeposited soils, we have a reasonably well-preserved site that really contains the occupation from one particular period, that period during which Brewerton projectile points were in vogue. The site occupies this low terrace above what used to be a stream channel. That stream channel has long since been abandoned, no longer functioning, but there's another stream just to the north, a few hundred feet, and another tributary to the west, also 200-300 feet. So the conditions are still there to have made this a good place to live, but when that main channel filled up with sediment, when the stream abandoned that particular channel, that was no longer an ideal place to live. The streams that are there now are heavily incised. They've been altered by poor agricultural practices, filled with sediment, etc. They would make a terrible place for hunter-gatherers to live because there are no anadromous fishes swimming up there. There's no broad wetland with various sorts of vegetational resources for food and fiber, migrating birds, and that sort of thing. The charcoal sample, very often archaeologists have a sample, they get their radiocarbon date back, and it gives them a date very different from what they were looking for. They say, oh, it's a bad date. It's been maybe fertilizer from plowing the field, the fact that it's something like that. But I think this is a good date. It's just that it isn't telling us what we'd hope to learn. It's telling us that there's been some effect, some disturbance of those deposits some 600 years ago. The large quantity of firecracked rock is really interesting because you don't get that much firecracked rock. I don't remember how many, like 15 kilograms from 10 excavation units. You don't get that. I mean, it's a big pile. If you had, it would fill several construction grade wheelbarrows. That's how much we recovered. You don't get that much from just cooking stuff in pots. There's something else going on. There was something else going on out there that resulted in all these firecracked rock. My guess is it had to do with processing on a large scale, not in a pot, large scale of food and or fiber. And what I mean by that is it could be that they were heat drying or smoke drying or whatever. They were processing fish from these herring runs. It could be that they're processing marsh plants for fiber. I don't know. The preservation doesn't tell us. There's a large quantity of flake stone stone from this site, mostly the waste product of making stone tools. So clearly they're going there, and you saw from the pictures, there's a lot of gravel around there. There's some big pebbles that's really good for making stone tools. So maybe one of the reasons they came to the site, apart from the relics, the stream, and whatever food resources and fiber resources it provided, it may be that one of the draws there was just excellent material for making stone tools. And then finally, these projectile points have been heavily reworked. And it reminded me of a project I did in my youth with Mike Gramley up in northern New Hampshire, a site called Mount Jasper, where there's this stone quarry up at the top of the mountain that Native Americans quarried out this rhyolite. At the base of the mountain, they had a workshop where they brought the blocks of rhyolite down and they whacked away at it and made stone tools. We found lots of projectile points, all of them worn out, just like what you saw here. And the thing there is that none of those projectile points were made out of the local rhyolite. They were all made of chert from elsewhere in the region. And so what Mike figured was going on is these folks were traveling around the countryside. They got to this place where they know they had good tool stone, good material to make stone tools, a river there, lots of food and everything. And basically they took their old worn out stone tools and threw them away and just replaced them. And I think that's probably what happened at the Westwood town site as well, that they got to this point and there was a lot of deferred maintenance. And when they finally got to this place, they go, oh, great, we finally got lots of material we could work with. These old things, they're worn out, we throw them out, we make new ones. So I think that was part of the draw at this site. At any rate, these are observations. Analytically, we really need to look at similar sites in the area. Unfortunately, there's not a lot of excavation of Native American sites going on right now, nor has there been in the last several decades. And we're really looking for sites that have a single component where there's one time period that's represented. Either stratigraphically, it's separated from others, or maybe spatially. It's a site with lots of material from different periods, but over in one corner, you find, let's say, Brewerton points. So anyway, this kind of contributes to a larger database, but I think there's a lot more we can learn from the site when we start comparing the temples. So anyway, that's all I've got for this evening. I'll entertain questions.
When you talked about the biface projectiles, is that the same thing as a cash blade?
No, cash blade is a term used for these. And I don't know about the scientific validity. It's a category, But a cash blade are these very large bifaces. I mean, so large they really couldn't possibly be used. Mm. They're just too big and too thin and too finely made that they would probably break. That's my understanding of a cash blade. Other folks might include larger, thicker bifaces. They're still bifaces, they're flaked on both sides, but they're clearly meant as sort of a core from which you can knock off flakes to use by themselves as tools and eventually turn that large biface into something that's more usable as a knife or turned into a projectile point. Also, cash blades are called such because they're usually found in this, a cache, a cluster, piled in, in a small pit or something. You get a whole bunch of these things together. So clearly they're being as we say, curated. They were being um, conserved and kept for some future use. The bifaces I'm talking about, I'm using the more typical term, which is just a stone tool that's created by flaking on both sides. So it tends to be kind of lentil shape in cross section. And it's perfectly usable as a knife, but also can be a source of flakes that you can knock off a sharp flake and just use the flake and not the biface. So the biface is both a tool and potentially a core, the source of material for making other tools. Sorry if that was long-winded.
That's good.
Any other questions?
Well, the other thing that occurred to me as you were showing me the analysis with the scans point, it might be a good application of artificial intelligence to build up a database like that.
Well, let me lay out the sort of situation. We have a 3D scanner, a tabletop 3D scanner. Bernard Means at Virginia Commonwealth University has been using these scanners for years, demonstrates them at professional conferences, teaches their use at the university. So he has students producing basically epoxy or plastic replicas, and they even paint them. They sort of kind of recreate the colors and the textures. And it's kind of a museum application. It's a way of producing replicas that you can use for teaching purposes, replicas that stand for the originals, perhaps could be used in a variety of exhibits that don't call for the originals. I wanted to find a use for the scanner that was more analytical, and this was our first attempt at trying to do that. Let's not just make what we already have. We scan without any intention of printing these things, of making replicas.
Right.
We want them for the images, for web use and whatnot, but also to figure out how can we use this technology analytically. And this is just my first stab at it.
Yeah. Well, so I was thinking that if you had those images in a database, that if you wanted to compare it with something else, I mean, the artificial intelligence can kind of take a look at that and say it fits into that category like these.
Yeah. We'd need somebody better versed in that technology than I am. But yeah, I mean, AI can be used in many ways. I mean, who knows, next year, with this lecture series, I might not be here at all. This all might be computer generated. And maybe the talks will go better. I don't know.
Is it Jim or is it AI?
Yeah, is it real or Memorex? As we say back in the 80s, I guess. Yeah, more sophisticated digital technologies could be brought to bear. But the thing is, those technologies aren't going to ask the questions. That's what we do as people. So with that crude example, I've asked the question. And now it's up to folks who are into these technologies, know how to use them, to figure out, okay, how can we deploy them on a large scale to further explore that question? That won't be me. I have trouble enough sometimes with Zoom. Yeah, other questions?
Jim, is there a way to estimate the size of populations that contributed to the findings here, and whether it was, and how that compares to what you might find in terms of samples in other locations, or maybe that doesn't even have any bearing? I don't know, but I'm just sort of curious as to, with the number of points that you found in that relatively small area, what does that tend to indicate?
Well, it's an interesting question, and one that archaeologists were dealing with when I started in the field back in 1976. And they continued asking those questions for a couple of decades. Can you estimate group size based on some archaeological parameters? And folks would come up with estimates. They'd come up actually with, site sizes, how how many meters in diameter does a site need to be to accommodate even a small family, a small extended family. Judging from the fact that we don't do that much anymore, tells me that nobody was particularly satisfied with the results. And the problem is, it's really hard to find well-preserved sites. Even what we were looking at, I showed you one of the early images, how that material was sort of clustered off the southeast corner of the barn. My guess is that site was much larger. Even the Brewerton component was much larger. But we've a small sample, only 10 excavation units, 5 foot on a side, and a relatively small area. And that area was defined probably because a lot of the deposits around it had eroded away as well. So there's so many limitations on a site that you have to frame your questions knowing what those limitations are. So what I'm saying here is we don't know how large that Brewerton component was before parts of it were destroyed through plowing and erosion. And if we don't know how big it was, we're probably not going to be able to figure out how many people live there. And, if it was a well-preserved site, we could find its horizontal limits, we might be able to find, okay, there's a hearth over here with piles of fire-cracked rock around it. There's another hearth over here, and start actually identifying individual households that were part of this aggregate of people. And then if you have total number of hearths, you can guess, okay, let's just say for argument's sake that it's 10 people per hearth, then 10 multiplied by the number of hearths. Or we could do a range anywhere from 5 to say 20 people. At least we can come up with ranges. But we're really dealing with a remnant of a site. And although it's one component, it's not a well-preserved one. There's been a lot of movement of soil, so we can't identify individual camps, individual hearths, individual households. If we could.
It's a challenge to excavate a Piedmont site versus a big river site with a big buried terrace. Jim, you really took a Piedmont site and you looked at it from many new tools that we didn't have 30, 40 years ago, or the questions.
Maybe I'm just looking in the wrong place. Maybe what I need to do is go further inland, like Bob Wall, and going up around Cumberland, where you get these, working along these rivers, where you get these really deep stratified deposits that have not been affected by plowing, not affected by anything. They go, some they go down a couple of meters, 6 feet and more. And you could find layers where you could begin to answer those kinds of questions. How many people lived here if you expose enough of it? But even then, we're limited by our desire to preserve portions of the site, and also the practicality is, how do you expose the entirety of some sort of site that's buried under, let's say, 4 feet of sediment? You have to do some serious earth moving to do that.
The Westwood site was a CRM project or just purely research?
It was a CRM project, but like a lot of my CRM projects, these, digging for dollars, commercial archaeology. Once the contract's fulfilled, I still have all those data, and for a while, the collections. And so I bring them back to the lab and we go to town on them. It's stuff we can work on and revisit, anytime in the future. I don't draw a clear line between my commercial interest and my research interests. The commercial interests help provide data for my research interests, without having to go through the trouble and risk of writing grant applications.
It was a great analysis tonight, very thorough, and you're taking the data and going much further with it than most of your colleagues would.
Well, thank you. I'm glad you appreciate it. You might hear it again. I plan on talking about the Mid-Atlantic Archaeology Conference first weekend in March.
Good.
Speaking of which, a number of our folks will be giving papers at that conference. A number of the folks from Smithsonian Environmental Research Center. We're looking at a total of 9 papers at this point.
That's great.
So we'll make a bit of a splash, I think. Any other questions, comments,
Jim,
criticisms?
and yeah, I've got a question. In some of your other talks, where you've gone and done some site digs and what have you, there have been factors, visible factors around that area which you utilize to sort of get a sense of the probability that there might be a find within that geographical area. Are you saying that this is an area that had been dug before and you knew there was some evidence there? And but either way, what were the factors in this area that you observed that would have given insight as to probable use?
Well, we didn't learn about people collecting the site because I'm not a local. I don't live down there. Until after we found the site, we learned that folks been collecting it for years. But I'm going to say 2 years earlier, again, further to the east at this large turf farm, we did an archaeological survey. And because they've been harvesting turf there for who knows how many years, there was really nothing left of archaeological deposits. All the soils are gone, you know? So we were digging holes over these immense fields to absolutely no purpose because we weren't going to find anything. However, walking around the property, I noticed that it was very clearly an old stream valley. I mean, you could see the channel of this stream with the banks and everything, just no water in it. And so I already knew about that and had already pieced together and try to plot where that relic stream used to go. And it looked like, there was some intervening developments, but it looked like it cut across the field that we were ready to survey. So I had an expectation we might find some interesting Native American stuff. I didn't know what period or, probably multiple periods. And we started digging shovel test pits, but as we got down towards the barn, one of our crew, I think it was Sarah Grady, actually, who was, just kind of looking at the surface and she said, Jim, we don't really have to dig. Look at this stuff. You could see it on the surface, even though the field had not been plowed recently. It was all covered over in grass and brush and everything. You could see the gravel on the surface and you could see flake stone and firecracked rock. I mean, it was just in your face. It took no skill at all to find the site. And indeed, in most cases, it doesn't take skill to find archaeological sites unless they're deeply buried. It's just, you get used to looking for these things. It's what do you do with the site once you've found it? That's where the science comes in. Anybody can find an archaeological site. And when you get down on the coastal plain, you get along the major rivers, the bay and everything, there's oyster shell all over the place. Finding the sites, figuring out what you're going to do with them, that's the challenge. And it's really a challenge in this area, partly because so many of these sites have been badly disturbed by poor agricultural practices over the last 3 centuries. And partly is because we don't do a lot of Native American archaeology around here. A lot of it's focused on the early historic period. So it's really hard in Maryland, I think, to do this kind of work.